2, 1. All right, so continuing these polynomial functions, this little topic is on the nth differences in polynomial functions. And let's take a look, because there is actually a pattern that emerges, and you'll see that you can find out exactly what the nth difference is. Now, let's recall what these nth differences are. So if you have an input and it's coming into a function, and that particular function turns out to be a polynomial, that polynomial is going to provide you an output. So here is your output. So I'm going to assume you have an x, okay, and then you have your output y, and then here's your polynomial. So whatever polynomial that you have in some order of that polynomial. Now, calculating the differences, what that means is if you're going to input, okay, so if these inputs are basically changing just by 1, so if you're going to increase the input by 1, and then again you input, okay, increases by 1, and so on. So for instance, let's say, we were putting in, so let's say -2, -1, 0, 1, 2, and we're entering these into our polynomial functions, then they're going to spit out for us some outputs, all right? And I'm going to just show you. Let's take an arbitrarily, let's say maybe a quadratic. So f of x is equal to -2x squared, let's say plus 2x minus 1. And now if you wanted to calculate your difference, I'm going to create a table of values here. So for this table of values, we're going to create these differences as we're going through. Okay, so you have your input, and now that input starts with some. All right, I put it at -2, and then it just changes by 1. So now the key here is, it's going up by 1, right? If you have random inputs, then the nth difference is not calculated that way. The nth difference assumes that you're basically increasing your input by 1. And then, so if you increase this again by 1, you're going to get 0. You increase it again by 1, you get 1 and 2 and so on. So basically what you have some starting point, so some input, okay? And then all you're doing is you're doing this, plus 1, right? And then you have, okay, if you increase that by 1, you're going to get plus 2 and so on. So your output, y, so if I calculate my output within here, so I will substitute it into my polynomial. I'm going to just fill these in here. All right, so those are my outputs. And again, so this shouldn't be new to you in terms of the differences and how to calculate. This is just a table of value. Now, your first difference, basically what it does is it takes your outputs and it subtracts them. So it will subtract the output for -2 and then -1 output. So -13, it's going to have minus -5. So it's going to be plus 5, and that's going to be -8. Then it's going to take the difference again between these two. So your next output that you have, and that will be -5 minus -1, which is going to be -4. Then it's going to take these, okay, and subtract those. It's going to be -1 minus -1. So that's 0. And then finally, it's going to take that. So that would have been your first difference. Difference meaning subtraction. And so here, we're going to get 4. Now, your second difference, in this case, so your second difference, because our order, so here is the quadratic, then that basically is your nth difference. So your nth difference, in this case, would have been our second difference for us because we have a quadratic. If that was, let's say, a cubic, then that would have been the third difference that we were searching for, and so on. So now here, when you do this, and you may recall from doing this in quadratics that you're going to get a constant. So here, so it's going to be -8. So here's the difference between the next two. So that's going to give me -4. And then I'm going to get -4 minus 0, which again is -4. And then 0 minus 4, which is -4. So you notice that, oh, okay, so they're constant. And that is nothing new. So it turns out you can do this for any polynomial that you like. You can take a third order, fourth order, of course, it's going to get more complicated and the table of values is just going to get bigger and bigger. But you're going to find that the nth difference of a polynomial, a, is going to be constant. It's going to be the same. Now, we can actually say a little bit more. If we would do this for any polynomial of nth order, you will actually find that the difference is equal to the constant that we have, so our first constant right here, multiplied, so this is going to be multiplied by n, multiplied by n minus 1, multiplied by dot, 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 all the way up to 1. Now this right here, when you do a multiplication, this in shorthand in math, you might have run into this, this is called n factorial. Okay, we do this exclamation mark and it represents the factorial, and it's just a multiplication of all of these factors. All right, so I'm going to write it out. This might be the first time maybe you see this in kind of grade 11 video right here, but that's how we would write it out. So this is interesting because without doing all of this mess, you know, first, second, you know, and so on. I mean, imagine if it was to the third order or fourth order, and then you have to do all of these differences. Instead, what you can do is you can literally take, so here, notice, -2. So this would have been our, so our result in our case was -2 multiplied by, now n factorial would have been just, so this would have been just 2 times 1, because our order n was 2. And notice what this equals is -4, which is exactly what we got here. And you can try that for any. Now, in grade 11, in terms of showing this, you can show this for general polynomials. And it's interesting to show. And what I typically do in terms of showing it, I create these as my inputs. Then I calculate my outputs. And yes, it's going to get messy. And then I start taking the differences. And you notice that your terms, your lower terms, so all of these terms, starts to fall off. The more differences you take, the subtractions will just cancel them off. And that is because we're only increasing our input by 1. And if you increase your input by 1 and start taking the difference between them, there's a lot of cancellations. And the only thing that happens after the nth difference is that your first constant remains, an, and then just a multiplication of your exponents. And that is pretty cool to be able to see that. Once you get into higher level maths, so for example, once you start studying calculus a little bit and you talk about derivatives, you'll notice that the nth difference for polynomials and the nth derivative of a polynomial are going to be kind of the same. All right, and you'll see that. I won't talk about that in this video because it's intended for grade 11, but it's to plant a seed for you as you keep studying on, and you can kind of remember that for yourself. And just as an added kind of bonus here, so here's another example for you. So to apply this, so if you wanted to know what the nth difference would be, imagine trying to do this for the fourth order and then creating a table of values. That would have been painful. Well, now instead, all you do is you simply take your highest order constant, okay, which is in front, so your coefficient in front of your x to the 4, and you multiply it by n factorial. And in this case, this is 4 factorial, which is just 5, times 4 times 3 times 2 times 1, and you'll get your answer. So it will be positive, and now you can calculate it. Well, this is 2, 6, 24. So 5 times 24. And this would have been, I guess, 120. And I would encourage you to try it. All right, to try to see this. You can even put it in like a spreadsheet or Excel file for yourself to save yourself time and be able to calculate it. Thanks for watching. See you in a future video. Bye, everybody.